What's up, guys? In this problem we are asked to find the value of k and the variance of 1 over x. In problems like these, you always usually start to find out the value of k. And before we start getting into the math thing, we need to first know if we are dealing with a probability mass function or a probability density function. And this is important because a PMF, when you are doing a transformation to the CDF, so you are integrating the function, here essentially it's a sum, and when it's a PDF, you are integrating the function in order to get the CDF. So we need to understand which one we are dealing with in order to solve the problem. And we know that here, when you are looking at this expression, that this is in fact a continuous distribution. So we are going to use this one in order to solve the problem. So let's do that then. K comes out and we have the function inside, so at x squared, and we distribute it between both elements. So x squared goes to 1 and x squared goes to minus x. So we have x squared minus x to the third power dx equals 1, always equals to this one. So continuing on, we have x squared goes to x to the third power minus x goes to the fourth power. All we did was integrate the values, and now we just need to plug in the numbers. And when you look at this, since this is 0, we are just dealing with this one. So essentially this is the same as having 1 over 3 minus 1 over 4. All this is equal to 1. So this one goes there, this one goes there, and we multiply these two. So we have essentially k1 over 12 equals to 1, which means that k is equal to 12. This is the answer for the first problem. Okay, we now know that the value of k is equal to 12. Let's find this one. We know from the properties that the variance of x is equal to the expected value of this one squared minus e of x, all that squared. So essentially we need to find these two elements with this expression. I'll give you an example. So the expected value of 1 over x, which is the first one that we're trying to find, which is this one, because we have this element inside. Let's find this one. So this is equal as, we're going to plug in this one inside times the function. So we have 12 outside from 0 to 1, and the expression is x squared minus x to the third power, because all we did was multiply and distribute these two terms, all that dx. So let's decompose the expression a bit. So we have 12 from 0 to 1, we have x squared divided by x, and we have x cubed divided by x, all that dx. So let's continue. We are not integrating yet, we're just simplifying the terms. So we are cancelling this 2 out. So instead of x squared, we are removing 1 from there. So we have x dx minus 12 from 0 to 1. We are removing 1 from this side. So we have x squared dx. We have not integrated yet. We're going to do that right now. Let me just change colors. So we have 12, and now x, integrating that, we have x squared over 2, and that between 0 and 1, minus, different color here, 12 over, so this is what, x to the third power divided by 3, all that from 0 to 1. So let's simplify the expression. So we have 12 times 1/2 minus 12 times 1/3. This is all we have here. So we have 6 minus 4, which is equal to 2. So our expected value is equal to 2. Let's continue. Okay, so now we have this one. We know that this one is equal to 2. Let's find the other one. So in order to find this one, the procedure is the same. we're going to get that inside of the function. So we are going to integrate from 0 to 1. We're going to get that element inside, so 1 over x squared times the function. The function, we know that it's x squared minus x to the third power. All that dx. This is what we have as the expression. So we are going to cancel these two out. Remember, we are not integrating yet. We're just canceling out some terms in order to simplify the expression. So we have from 0 to 1, we have 1 dx, all this with the 12 outside, minus 12, and we have from 0 to 1 again. X squared is dividing with this one, so 3 minus 2 is 1, so we have x dx. This is what we have. So continuing on, we are now integrating the function. So 1, when you're integrating that, so it leaves 12, so 12 outside, x from 0 to 1, minus 12 again, and this guy is x squared divided by 2, again from 0 to 1. So this one is equal to 12, because 1 goes inside and 12 multiplies by 1, so we have 12 minus, and then we have this one that goes inside, and 1 to the second power, 1 squared divided by 2 is 1/2. 1/2 times 12, or 12 divided by 2, which is the same thing, is 6. So 12 minus 6 is equal to 6. Therefore, when we are taking this second expression and plugging in all those numbers, we're going to get the variance of 1 over x is equal to the first element that we got, we already know, and we are starting off with this second element. So x minus the first element to the squared. So this is equal to x minus 4, which is equal to 2.